In this video, we're going to be factoring quadratic expressions, particularly trinomials, 1, 2, 3 terms, where the a value is always 1. That does make these problems easier because of the lack of factors for the number 1. One thing that's important to understand is when you factor a quadratic trinomial, you can expect the answer to be in the form of 2 binomials being multiplied together. And so we're basically going to be undistributing a trinomial, creating its factors that were multiplied together to achieve that. So I'm going to show you some tricks that will help you establish those. And this is more or less the trial and error method. So let's go ahead and look at our first example. We have a quadratic trinomial. And because I'm factoring a quadratic trinomial, I expect the answer to be 2 linear binomials multiplied together. Linear means first degree. So we're going to start by figuring out how could I multiply to get x squared. Well, that will go right here in the front. And hopefully you realize that that is x times x. Because the process of multiplication for these binomials is to do that first. And that would give you x squared. So we're going to make sure that this builds this trinomial when we're finished. The same is true for the very last term. I'm trying to get a 10, and those two numbers will get multiplied here to achieve a 10. And the answers, the options there is maybe it's 1 times 10, maybe it is 2 times 5. And for the examples where the a value, right here's the a value, where it's 1, I don't have to worry about the order in which these numbers go. Here is why. If this was a 1 and this was a 10, the multiplication would occur like this: 1 times x, which is 1x, and then you would do 10 times x, which is 10x. And if I had those flipped around, say the 10 was here and the 1 was here, I would still be getting a 10x by multiplying these together, and I would still be getting a 1x by multiplying those together. So the order wouldn't matter here because this and this are the same. So flipping them around doesn't create new products. And that will occur anytime the a value is 1. So is it 1 and 10 or is it 2 and 5? The answer will actually be the 2 and the 5. Here's how I know. If I put a 2 here and I put a 5 here, the products would have become 2x and 5x. And I was trying to achieve a 7x. Now I know it says negative 7x. I'm not concerned about that right now. But I use this symbol right here to indicate what I'm supposed to do with those products. So I'm supposed to add those together, and it will give me a 7. And now that I want them to be a negative 7x, I need to think about what signs go here and here. So there are 2 ways to think about that. One, if I was going to multiply to get a positive 10, that means that not only does it mean that I will be adding those products, but it also means that the signs had to be the same, that these signs have to be the same. And since I'm trying to achieve a negative 7x, then that means they're both going to be a negative sign. Now, it looks a little messy because of my extra notes, but your final answer is this: x minus 2 times x minus 5. The first example is always going to seem a little bit crazy, but once you get this down, it'll really speed up your factoring and understanding of what factoring is for a quadratic trinomial. Let's go ahead and look at another example. Once again, I have a quadratic trinomial, and so I expect my answer to look like a binomial times another binomial. I see x squared, so I say x times x. That's the first multiplication that would occur. It's going to give me x squared. Now I look at the back term. It's a 27, and I'm going to be subtracting. Now, since these are ones, it's really easy to understand that whatever number goes here will just be multiplied by 1x, and whatever number goes here will also be multiplied by 1x. So I'm going to start coming up with numbers that can multiply to give me 27, but then they will subtract in order to achieve a 6. So what numbers can multiply to give me 27? You can make a full list if you wish, but some of us may already know the answers. 1 and 27, and 3 and 9. So those are the only two pairs of numbers that will multiply to give me 27. And which of those can I subtract to get a 6? Well, that's a 3 and a 9. So I'm going to put a 3 here and a 9 here. And I want to get a positive 6. So there's something we need to figure out about our signs. We are subtracting, and the reason we're subtracting is because the signs are different. So one of these is a plus and one of these is a minus. And since we want a positive 6, I'm going to put the plus sign on the larger of the two numbers. So that means this is a plus 9 and this is a minus 3. My final answer is this: x minus 3 and x plus 9. If I were to multiply this back together, I would get x squared, negative 3x, positive 9x, which becomes a positive 6x, and then negative 3 times positive 9 is negative 27. And that's how you know you've done this the right way. Let's do another example. On this problem, you may notice that this number is not a 1, but actually a 3. In this lesson, I'm doing only problems that have an a value of 1. So how does this become a 1? Well, you should recognize that there's a greatest common factor. If you're unfamiliar with factoring out a greatest common factor, I'll have a video about that. You can check it out. The greatest common factor here is a 3. So I'm going to factor a 3 out, and then the remaining trinomial would be x squared minus 3x minus 4. The 3 is a factor, so I leave it there, but the orange trinomial will factor into two binomials like we did before. And now you may notice that this a value is a 1. So how can I get x squared? That's going to be x and x. And now I need to find factors of 4 that I can subtract to achieve a 3. So the only two options are 1 and 4 or 2 and 2, because 1 times 4 is 4, 2 times 2 is 4. Which of those pairs of numbers can I subtract in order to get a 3? Well, the answer is 1 and 4. So I'm going to put a 1 here and a 4 here, and I'm trying to achieve a minus 3. Remember, signs will be different. That's how I knew I was going to subtract those products. And so I'm going to put the negative on the larger of the two numbers here, and that is the 4, and that's the plus there. So this one, because there was a greatest common factor, my answer is actually 3, x plus 1, and x minus 4. If you're needing to see some more examples about this, please let me know. This is the most basic style of factoring, and that was because the a value was always a 1. I hope this helps.